Hello everyone. So in this session we'll see another problem on area by double integration for polar coordinates. So the question is as such, which is find the area of the region that lies inside r equal to 3 plus 2 sine theta and outside r equal to 2. So we have got two curves here. First curve is r equal to 3 plus 2 sine theta, which is a lemma, and C2, which is r equal to 2, which is a circle. So first of all, let's try to understand this curve. So these are the curves, and this one is C1, which is 3 plus 2 sine theta, and this one is C2, which is 2. Now, the region which is inside the lemma and outside the radius or outside the circle will be this one. So first of all, we need to see what are the angles here, like theta varies from in what range. So for that, we need to find the intersection point. Like we can see this is one of the limit and the other limit is here, as these two are the intersection point. So we'll have to find the intersection point. We can see like both the curves have to be equal. So for the point of intersection, 3 plus 2 sine theta needs to be equal to 2. So 2 sine theta should be 2 minus 3, which is minus 1, and sine theta should be minus half. So sine theta minus half needs to be in the third and fourth quadrant. Like we can see, this is our third and this is our fourth quadrant, and this is where the point of intersection lies. And this will be like sine theta equal to half. So sine theta equal to minus half can be possible when it is 180 plus 30 degree, or when it is, you can say, 360 minus 30 degree, like that. So that is 330 degree. So if we are writing this in terms of, let's say, radians, so theta, this theta is actually pi and pi by 6, so 7 pi by 6, and this one is like 12 pi by 6 minus pi by 6 we can write, so that will be 11 pi by 6. Now, so you can see like if you say the theta varies from 7 pi by 6 to 11 pi by 6, this means you are moving from this angle, which is 7 pi by 6, to 11 pi by 6. But this is not what we are looking for. We are looking for a variation from this region to this region. So for this we'll have to do two things. Either we'll have to add 2 pi in this 7 pi by 6. So the lower limit could be 11 pi by 6 to 7 pi by 6 plus 2 pi, or otherwise we can start from the negative angle, that is we can subtract 360 from this, so that will be minus 30 degree. So from minus 30 degree, like moving to 0 and then positive angle and then reaching to 7 pi by 6, this is also possible. So we can do it like either way. So let us do it in this sense, like theta starts from minus pi by 6 and goes up to 7 pi by 6. We cannot do 7 pi by 6 to 11 pi by 6. That will mean in this region, this will be that region. So we are not interested in this region, we are interested in this region. So it could be either of the way. Either it could be 11 pi by 6 to 7 pi by 6 plus 2 pi, or this one. So let us follow this one. And if we talk about the radial variation, we can see that the inner limit will be on the circle or the curve C2, and the outer one will be on the limicon, that is C1. So that will give us the limit for R here. So we can say that R will vary from 2, 3 plus 2 sine theta. So we have got the limits for both theta and R. Now we can find the area of the shaded region. So area will be given as theta from minus pi by 6 to 7 pi by 6, and r from 2 to 3 plus 2 sine theta, and the limits are going to be like the values are r dr d theta. This is what we need to do here. Double integration in this term will get us the region area. So r dr will give you r square by 2. The limits are 2 and 3 plus 2 sine theta. After putting the limit, we need to integrate this with respect to theta with range minus pi by 6 to 7 pi by 6. Now put, like, we can take this 1 by 2 outside. For r square, this is going to be 3 plus 2 sine theta square minus 2 square. Integration from minus pi by 6 to 7 pi by 6 in terms of d theta. Okay, so with this 1 by 2 outside, minus pi by 6, 7 pi by 6. Okay, so inside we have got 9 plus 4 sine square theta, and 3 to 6 and 12. So plus 12 sine theta minus 4 d theta. So this is 1 by 2 minus pi by 6, 7 pi by 6. 9 minus 4 is 5, and 4 sine square theta. So again, sine square theta, so we know that 2 sine square theta is 1 minus cos 2 theta. So as per that, this is going to be plus 4 sine square theta will give us 2 minus 2 cos 2 theta plus 12 sine theta. Okay, now so 5 plus 2 will become 7. So 1 by 2, 7, 7 theta minus 2 cos 2 theta will give us minus 2 sine 2 theta by 2 plus sine theta. So integration of sine theta will be minus cos theta. So we can say this is going to be minus 12 cos theta, and the limits. So the limits are minus pi by 6, 7 pi by 6. Okay. So for the constant part, that is 7 theta, 7 pi by 6 minus pi by 6. So that will be actually 7 and minus 1. So that will be 8. So that is going to be 7 times of, let's put the values, plus pi by 6. Minus 2 by 2 will become 1. So sine 2 theta. So sine 7 pi by 6 into 2. So that will be sine 7 pi by 3 minus sine, so 2 theta, so 2 times of minus pi by 6, so that will be minus pi by 3, and sine minus pi by 3 can be written as plus of, so sine pi by 3, and minus 12 times of cos of 7 pi by 6 minus cos of minus pi by 6. Instead of that, we can write minus cos of pi by 6 directly, because cos is even function. So this is what we'll get, and we need to find the value. That's it. So 8 pi by 6 and 8 times of 7 minus root 3 by 2, and sine 60 will also be root 3 by 2 minus 12 times of minus root 3 by 2 and minus root 3 by 2. So if we can reduce this further, taking 2 as a common factor, so this is 3, this is 28, and further with 1 by 2, this becomes 14 pi by 3. So overall this is minus root 3 minus and minus plus 12 root 3, so that will be 11 root 3, and then half outside, so by 2. So that is actually 14 pi by 3 plus 11 by 2 root 3. So this is the area for the region outside the circle and inside the lemma cone found by double integration. So I hope you would have understood after this all of calculation part. Thank you.